This is the fourth video of a series on straight line. The first video covered gradient and the gradient formula. Here it is here. The gradient m is the y difference over the x difference of 2 points on the line. Second video covered y equals mx plus c, the general equation of a straight line, gradient m, passing through 0c on the y-axis. The third video looked at the general equation of a straight line, gradient m, through a point AB. Going to go over an example which was used in the third video, just to introduce this video, which is on rearranging the equation of a straight line. So here, the line passes through 2, -1 and 8, 2. The gradients from that gradient formula, y difference over x difference. I'm going to take top point minus bottom point here. Y coordinate 2 minus the y coordinate -1, that's on the top line. The x coordinate 8 minus the x coordinate 2, that's for the bottom line. So, y difference 2 subtract -1, that's 3. The x difference 8 minus 2, that's 6. We've got 3 over 6, which is a half. The gradient's a half. General form of a straight line, y minus b equals mx minus a. M is a half. AB is some point in the line. Easiest point's 8, 2, because it's got no negatives. But I'm going to use the other point, 2, -1, to show you how you've got to watch the negatives. So I'm going to make A2 and B -1. This x coordinate 2 goes with the x. This y coordinate -1 goes with the y. This is the x difference, and that's a y difference. So you've got to have x coordinates with x coordinates, and y coordinates with y coordinates. So A2, B -1, there they are substituted. X coordinate 2 went with the x, y coordinate -1 went with the y. This is subtracting a negative, that's the same as adding. So this is going to be y plus 1. Everything in the brackets has got to be multiplied by this half. A half times x and a half times 2. So that's the brackets broken, and that's this subtraction of a negative tidied up to be a plus. Tidy up further, I'm going to take 1 off the left and 1 off the right, and there's the equation of the line. It's of the form y equals mx plus c. I can check that's correct by looking at the points in the line and seeing if, take the x coordinate, half it, and subtract 2 produces a y coordinate. So here it is up here, take x coordinate 2, half it, and take off 2, it does give you -1. Here the x coordinate 4 is 8, half it to 4, and subtract off that 2 does give you 2. So this equation, which is connecting the x and y coordinates of any point in the line, works for these 2 points. It's a check that you've got the correct equation. So in this video we take this equation of the form y equals mx plus c, and we simply are going to rearrange it. So here it is here. First I'm going to get rid of the fraction of half by doubling both sides. Multiply the left by 2, multiply the right by 2. This y get multiplied by 2. The whole of this right hand side get multiplied by 2. Half x times 2 is 1x. 2 times 2 here is 4. I'm now going to subtract 2y from the left and balance it by subtracting 2y from the right. This was so that 0 was left behind here. So 2y off each side. And since 0 equals all this on the right hand side, this on the right hand side is the same as 0. I'm just going to write it from right to left. There it is. X minus 2 minus 4 equals 0. Things haven't changed side here. I've just said what's on the right is to be 0. So there it is, equal to 0. Now, I've got it in the form ax plus by plus c equals 0, where a, b and c are 3 numbers. It's 1x here, a is 1. It's -2y here, b is -2. It's a constant here, as it's got no letter on it, no variable. It's -4, c is -4. So a, b and c are 3 numbers. A is 1, b is -2, c is -4. That's this equation is of this form. it's a rearrangement of y equals mx plus c form. I like it with a positive x here, so whenever I write it in form ax plus by plus c equals 0, I want a to be positive. Now, if this is the equation of the line, which it is, these points should satisfy this equation. That is, if I make x2 and y negative 1, in this equation, it should make the equation true. So here's a check. I'm going to make x2 and y negative 1, 2, subtract negative 2, well that makes 4. Take away that 4, does give you 0. When I made x2 and y negative 1, the left hand side worked out to be 0, as it should. That means 2 negative 1 lies on the line. If I do the same with 8, 2, make x8 and y2, 8, take away 4, well that is 0. So 8, 2 satisfied the equation. It made the equation true. 8, 2 lies in the line. So that checks that these 2 points lie in the line, they fit the equation. I could also find out whether a point lies above or below the line. So here's the same line of this form. So this is the same line passing through these 2 points. Does the point 6, 0 lie in the line? Does 6, 0 fit the equation? And if it doesn't lie in the line, is it above or below the line? You can find out by doing the following. Since this is the point x6, y0, put x to be 6 in the equation and solve that equation for y. So I'm going to take that 6, subtract 4 is 2. So the left hand side's got 2 on it. I'm going to take 2 away from the left and 2 away from the right. That way I've got negative 2y equals negative 2. So y is negative 2 divided by negative 2, which is positive 1. So if x is 6, y should be 1 if the point is on the line. So 6, 1 is on the line. Well, 6, 0 isn't. Now the y coordinate here is 0. That's less than 1. So 6, 0 is below the line. There's a diagram to show it. There's 6, 1 on the line. 6, 0, 1 unit below that. So 6, 0 is below the line. 6, 2 would be above the line. So you can tell if a point lies on the line or if it's above the line or below the line by substitution of the x coordinate and working out what the y coordinate should be. That's one use for this rearranged form. What we quite often have to do with it is actually change it back to the form y equals mx plus c. So we will be given the equation in this form and you'll be asked to find the gradient. So you need it in the form y equals mx plus c because m's the gradient. What I'm going to do here is I'm going to take that minus 2y onto the right hand side because it's a negative y term. I don't want negative y equals, I want positive y equals. I want a 1y equals. So I don't like the negative y term. Add 2y to both sides. So add in 2y to the left. That cancels off the minus 2y. Add 2y into the right. Now I'll write that backwards. Simply because I want what y equals. I'll write 2y equals x minus 4. Divide the left by 2 and divide the right by 2. That now means x gets halved and the 4 gets halved. I've halved the left, I halved the right. It's now the form y equals mx plus c. M is obviously a half. That's the gradient. The gradient is a half. So from this form of the equation, I've worked out the gradient by rearranging it into the form y equals mx plus c. That's the commonest use for this general form. You're given this general form in the question and you have to rearrange it to find out the gradient. So here's 2 lines. I'm going to work out the gradient. So what I do is I take this one here and I rearrange it so I get 3y equals and then I get y equals. So I want the 2x to go to the right and I want the minus 6 to go to the right. I take 2x off each side. I add 6 onto each side. So there it is. Take 2x off the left, take 2x off the right. Add 6 onto the left, add 6 onto the right. Or you can use change side, plus 2x being minus 2x, minus 6 being plus 6. Divide everything by 3. Divide the left by 3 and you'll get y. Divide the right by 3 and you get negative 2/3 here and you get 2 here. the gradient is negative 2/3. Just by looking at y equals mx plus c, m is negative 2/3. That's the gradient's negative 2/3. For this example, because that says minus 2y, like the example in the previous slide, I will be taking that minus 2y onto the right. In other words, I'll add in 2y to the left and I'll add in 2y to the right. I'll now write it by division by 2, divide the right by 2, divide the left by 2, 5/2 here, 4 here, halving the right, half everything on the left. And now I'll just write it the other way around. Y equals 5/2x minus 4. Gradient is obviously 5/2. So, from this form of the equation, you rearrange it to y equals mx plus c and pick out the gradient. So this uses this in this question. Suppose you're getting a line that passes through 4, 3. So it's a line through 4, 3. And it's to be parallel to this other line with this equation. So I know a point in the line, I want the gradient of the line. The gradient of the line is the same as this other line because they're parallel. So I take that equation, rearrange it to the form y equals mx plus c, and there's the gradient. So notice 3x and the minus 4 went over to the other side and I divided through by 2. That's the form y equals mx plus c, and there's the gradient, negative 3/2. So this other line through 4, 3 has gradient negative 3/2 and it passes through 4, 3. There's a general equation. The gradient's negative 3/2 and it passes through 4, 3. A is 4, B is 3. X coordinate 4 goes with the x. Y coordinate 3 goes with the y. Now, I'll leave it in the form y equals mx plus c, so I'm going to multiply away the brackets, negative 3/2 times x and negative 3/2 times negative 4. Negative times negative is positive. If I want to multiply this 4 by the 3/2, I divide by the 2, the bottom number of the fraction, and I multiply by the top. So take 4, to multiply it by 3/2, divide by the 2 and multiply by the 3. And that's why it's 6. It's a negative times a negative is positive, and it's 3/2 times 4. Divide by 2 and times by 3. Now just get rid of this minus 3, add 3 to each side, and that's the equation. So that's passing through 4, 3, and it's parallel to this other line, so I rearrange this other line to get the gradient. So, if you click the link in the description, there is a worksheet practicing each of these things that were shown in an example, finding out if points lie on, above or below a certain line, rearranging to the form ax plus by plus c equals 0, and rearranging to the form y equals mx plus c to pick out the gradient, and then like that last example, a line through a certain point parallel to some other line, so you have to get the gradient of the other line. The answers are on the worksheet. When it came to the answers to question 3, to rearrange to y equals mx plus c and write the gradient, what I did was I simply put the gradient in blue because there wasn't room to get all the answers in. So if you click the link in the description, there's a PDF which is the same PDF used for the other videos. First video was in gradient. There's a gradient exercise with answers. Second video was in y equals mx plus c. There's the exercise in y equals mx plus c with the answers. Third video had y minus b equals mx minus a. There's x exercise with the answers. And on the same PDF for this video is the straight line equation being rearranged. That's the questions. The answers, which are a wee bit squashed in, are on the sheet. So if you click the link in the description, you get access to that worksheet with the answers, and the set of notes is there, which covers all the videos in straight line. That's the gradient. That's the gradient as well. That's y equals mx plus c, and some rearrangement there that occurs in this video. And that's third video, y minus b equals mx minus a. And the next video is on scatter diagrams and line of best fit. It involves statistics, so this is related actually to statistics, but it uses the straight line work. So I've included this piece of work, line of best fit, with straight line videos rather than the statistics videos. Hope you found this video useful. Thank you.